Hello little kittens, welcome to lesson 4.4, Similarity Transformations. Now we talked a lot about rigid motions and congruence. If two figures are congruent, then we know there's a set of rigid motions that map them onto each other. But what if they're similar? What if they're similar? Well, there's a thing that's called similarity transformations. And similarity transformations will map two similar figures onto each other, such as like here. We'll talk about that in a second. So a similarity transformation is one or more rigid transformations, such as a reflection, rotation, or translation, followed by dilation. And that's our key word here, dilations. All dilations are similarity transformations. Always, 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 always. Now here's a fun fact that you should know. If two figures are similar, then a transformation including a dilation will carry the first figure onto the second figure. And I want to check out to see if that actually works. Maybe I'm lying to you. Now we have these two triangles here, and these are similar. And we have these two triangles that are not similar. Now, even though they're not congruent, right, there will be a way to map them onto each other, and I could just use a dilation. Because if two things are similar, then a dilation will map them onto each other. So let's try it out. Maybe you don't believe me. So let's dilate this guy. We're going to make it bigger. Wop, 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 wop. And look, it mapped right over it. Okay, mapped right over it. Now these guys are not similar. So let's see if I can use a dilation to map them onto each other. Doesn't look like it's happening, right? So if two figures are similar, then you can use a dilation to map them onto each other. That's the big thing here. If two images are similar, then a dilation can map them onto each other. Let's try it out. So triangle DBF, this guy right here, is similar to triangle ABC. Describe a sequence of similarity transformations that maps triangle DBF onto ABC. Well, looks like here if I dilate this guy, I could probably map it onto it. Right? Well, I agree with you. So we're going to use a dilation, that's for sure, because these two are similar. If they're similar, then I know I need a dilation to map them onto each other. All right? But there's two things you need to know. You'll need to do a similarity transformation. You need to know the scale factor that you're using, and you need to know the center of dilation. Now we've talked a lot about scale factors, but we'll talk about it again. The scale factor is always the image, the length of one of the sides of the image over the pre-image. Now you could pick any side, it doesn't matter what side you pick, but you have to pick a side, and it's going to be the length of the image. You find your length of your image over the length of your pre-image. And that's your pre-image. So in this case, we see that our image, the length is going to be AB, right? That's the side length. And our pre-image is DB. All right? And you could have picked this side. It doesn't matter. All right? But you have to pick a side. So our scale factor is going to be AB over DB. But you know what? We can actually count these units. So let's put the units in. So it's 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 8 over, let's count our pre-image. 1, 2, 3, 4, 5. And I know what you're thinking, like, oh no, that's not a whole number. It's fine. Our scale factor will be 8 over 5, our image over our pre-image. Now we got to pick our center of dilation. Let's get all this junk out of here. Well, it's not junk, this beautiful math. Where's our center of dilation going to be? Where is this expanding from? Well, that would be point B, right? Because that's where it's going to be expanding away from. Our triangle is going to be moving up in this direction away from B, right? So B is our center of dilation. Well, now that we collected our important information, now we can use this information to write the similarity transformation. And what we would say is this. Just use this template when you're writing it out. It is a dilation with a scale factor of 8/5 centered at point B will map triangle DBF onto triangle ABC. All right? So the first thing you should always be doing is collecting your scale factor and center of dilation. That is huge. All right, let's try another one. Triangle DBE and XYZ are similar. Describe a sequence of transformation of the mass DB onto XYZ. Now looking here, it looks like we're going to be more than one transformation to get this going, right? So how are we going to get this to work? Well, before we dilate it, we need to do one rigid transformation. What is that transformation? You think of that in your head. All right, I'll tell you. I'll tell you. You should pause the video and try to figure it out, but I'll tell you. It's going to be a reflection over the x-axis. All right, it's going to be a reflection over the x-axis. All right, we're going to reflect it over. So let's do that reflection now. We're going to grab our triangle. We are going to reflect it. So, whoop, we got to reflect this guy. Let's see if I can use my nice little tool. Flip it up, down, and we reflect it over the x-axis. And look at that. We're in business, right? So, now that we've mapped it over, when this moves up, we have point E over here, and we have point D over here. Oh, we have point B over here, and this would be D over X, right? D's over there, but that's fine. So now that we got them looking good like that, we got to let's write out our scale factor and center of dilation. That's our important piece of information now. Now, I always like to pick straight lines. Like this one's kind of like, it's at an angle. I don't like doing that. So let's pick this straight guy over here. So our image, after this transformation, it's going to be XZ. All right, so that's going to be XZ on top. All right, our pre-image is XB. All right, so that's going to be our scale factor, our image over our pre-image. Well, we can actually count that out. So let me erase all this stuff. All right, so we can do some counting. It's going to be, let's count XZ, 1, 2, 3, 4, 5, 6, 7. And XB is 1, 2, 3, 4, 5. 7 over 5 is our scale factor. All right, just our image over our pre-image. We pick a side. Now, the reason I didn't pick this side over here is because you can't count across, right? I can't count like this. So it makes it really hard to do. You'd have to use the distance formula to find out this. I know you don't want to do that. So that's why it's easier to just pick a straight line like that, when it's just straight like that, okay? Where's our center of dilation? Well, when I look at this guy, it looks like my center of dilation is right over here, right? That's where we're going to be expanding away from. So our center of dilation is X. All right, now that we did our similarity, we found out our important information, our scale factor, our center of dilation, we are ready to write it, all right? So first we did a reflection over the x-axis. And then we did dilation with a scale factor of 7/5 centered at point X. We should probably use the word point. All right, and that maps triangle DBE onto triangle XZY. Well done, guys. Should we keep rocking? Yeah, I think so. All right, now we're going to be doing it without the grid, all right? It's actually easier. You're going to like this more. You're going to like it more. It's actually easier. So in this case, we are told triangle BED, which is this smaller guy right here, is similar to triangle ABC. We want to describe a sequence of similarity transformations that shows triangle ABED is similar to triangle ABC. Well, how are we going to do that? Well, what would we always need? You got to collect your important information. Always collect this. Always. You need this when you're doing your similarity transformations. You need your scale factor, you need your center of dilation. Now, since they're already mapped on top of each other, basically, I just need to dilate it at this point. So, let's find out our scale factor. Well, our image, that's our image, right? The length of one side of the image. It doesn't matter which one you pick. You could pick this guy, or you could pick this guy. It doesn't make a difference. Or you could pick this guy. Actually, don't pick that guy, because your center of dilation is right here. All right? Then you pick your pre-image. So your length of your pre-image is going to be right here, our pre-image. Okay? Well, now how do we do it? Well, what's our scale factor going to be? It's going to be AB, which is our bigger triangle, over EB. Okay? That's our scale factor. Our image over our pre-image. Where's our center of dilation? Well, things are expanding away from B. That's the point that's mapped onto each other. So we're going to be centering at B. So now, since there's no numbers here, we actually can't change it. Our scale factor is just this. All right, we're just going to keep this. We don't have to use any numbers. That's why it's easier. There's no numbers to work with. So all we have to say is that to map BED onto ABC, it's a dilation with a scale factor of AB over EB centered at point B. Point. And that maps triangle BED onto triangle ABC. Let's try one more. I think we're getting it, okay? Now, I'm not going to have all those boxes there for you to fill out all the time, so you're going to have to get good on doing this by yourself. So I'm taking the boxes away. I'm taking them away. Let's see if we can still do it. We want to map triangle WHY. Triangle WHY is similar to triangle CAT. Describe a sequence of similarity transformations that shows triangle WHY is similar to triangle CAT. Well, looking at these, what's our first transformation going to be? What's our first one going to be? That's correct. It is going to be a translation, right? Because this isn't a flip, it's not a rotation, it's just going to move it. So first we're going to translate it. Now you could pick any 2 points here. I think it would be good to pick HA. All right, so we're going to go along that line. So it's going to be a translation along line HA. And that's, guys, why I kept saying this over and over again. We always have to keep using the right language. A translation along HA, you got to say which 2 points you're going along. All right, so that's our first step. Now, when we move that, it's good just to draw it so you can visualize what's happening here. Okay? Whoa, 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 calm down. What just happened there? We can visualize what happened. So when we move it over, all right, when we move it, translate along that line, it's going to come over here, all right? And we're going to have W here, and we're going to have Y here. So now we have to translate, we have to dilate. Now we are in the dilation stage. So what do we need? We need 2 things, right? We need our scale factor, and 2, we need our center of dilation. All right? Like I said, you got to just do this on your own now. There's no boxes. Well, let's pick a line. This is going to be our image, all right? That's our bigger one, and here is our pre-image. So our scale factor is going to be CA over our pre-image is WA, right? That's before our transformation. And our center of dilation is going away from this point, so our center is A. So now we could keep writing. So first a translation along line HA, and then a dilation with a scale factor of CA over WA centered at point A maps triangle WHY onto triangle CAT. All right. Just using this template every time, a dilation with a scale factor of blank centered at point blank will map them onto each other. All right. Last one. Now, I'm not going to go through the whole thing with you. I want you to try it by yourself, then check your answer. Okay. So pause the video and then come back and check your answer. All right. Pause it now. I'm serious. All right, I'm going to write the answer down now. I'm kidding. Pause the video. Why aren't you listening to me? Pause it. See if you can do it by yourself, then check your answer. All right, so let's check out the answer here. The answer should look something like this. So first we rotated it, and we got it looking like here. And that was a rotation counterclockwise of 180 degrees around point D. Now that could have also been clockwise. It doesn't matter. But it needed to say the direction, the degrees, and which point you're going around. All right, that is step 1. Step 2, we got to dilate it, right? So we need a dilation with a scale factor of CE, that's our image, over BE, centered at point E, and that will map ABE onto CE. I'm dropping the mic. Boom. You guys should too. If you need any help, watch the video twice. I'm kidding. Come ask me for help. And hey, I got a little piece of advice for you today. This is a good one. Whenever you see your mother and she's in a bad mood, bring her a cup of hot tea. It'll make her feel better. Peace.